I think the best Cheerios are Honey Nut Cheerios. That's my favorite. Cheerios, regular Cheerios taste like cardboard, I'm sorry. I've never understood how you eat Cheerios by themselves.
They did that to us at camp where I worked this summer. They would, if we ran out of Honey Nut Cheerios, they would put normal Cheerios, and it's like.
I think I'd just rather just drink the milk in the bowl by itself than eat regular Cheerios.
Or just take the sugar from the
Now,
coffee station.
I tell you what's good. Have you ever tried the chocolate Cheerios?
Yeah, they're good.
Take the chocolate Cheerios and put chocolate syrup on top of it with milk. That's some good stuff. I'm a little bit of a closet chocoholic, so. And something else that's real good is take the chocolate shredded wheat and put chocolate syrup on it. That's real good if you're a chocoholic. I know there's some females in here that's probably chocoholics. All right, so here we go. We take our handy dandy spreadsheet and we just do it so y'all can see it, not that y'all have to use it. Copy, pull up our handy dandy spreadsheet. Vanna decided not to show up today. Can't find good help these days. She just cut class. And we'll put it right here. And there's our X and P of X. Okay, now the first thing we need to do is we need to take X and multiply it by what? P of X. So that's going to be equal to that times that. What's different about this column? Not different about this column. Must be the. I'm not going to worry about it. And add those up. And what is that called? Mean. What else do we need? Well, we need x squared, right? And that's equal to this quantity squared. I always have somebody say, well, Hubert, you can do that in your head. Yeah, you can do that in your head, but are all these going to be whole numbers all the time?
No.
No. Yeah, and they may not be decimals because you don't have 3.2 of n's, but you may have 27, 28, 29, and 30. And unless you're Rain Man, you're not going to know what 27, y'all know what 30 is. 30 times 30 is 900. But you don't know what 27, 28, 29 are unless you're Rain Man. So, you know, get in the habit of actually doing it on the spreadsheet or in your calculator so you know what to do. You go through that motion. And then take x squared times what? P of x. Make sure you pick the right column. And add those up. And that's part of your variance. And that's going to be equal to this guy minus what?
Mean squared.
The mean squared. And that's your variance. Your standard deviation is equal to that number raised to the 0.5 power. And there's your numbers. Mean goes in the middle. Add 1 standard deviation. And add another standard deviation. Subtract the standard deviation. And subtract standard deviation. So your normality falls between what? Negative 0.5 and 2.9. That's normality. So let's take a look at our handy dandy problem. No offense, but I don't trust y'all. Y'all set me up. So, all right, round to 2 decimal places. So that'd be 1.17. It's a miracle. 0.85. Is it unusual for a family with 3 children to have only girls? Well, only girls, which one is this one up here? Only girls. Is that, let's see, assume probably the child having X girls. Okay, so this is only girls is how many cents? 6 cents. What is the unusual representation? 5 cents, right? So is 6 cents greater or less than 5 cents? So then 3 girls is what? Normal or unusual? If it's more than 5 cents, it throws it into what? Normality. It throws it into the normal. Less than 5 cents, it's in the what? It's in the 2 wings over here, which is unusual. So 3 girls is what? Normal. So make sure you read this, because a lot of times I've answered the wrong question. Put the wrong answer because I didn't read the question. Is it unusual? No. So you said say no. So it's either B or C. And which one is it?
C.
C. So I know y'all can read. Good. Check answer. Look there, we got it right. It's a miracle. All right, now you should have 3 or 4. Count your notes if you don't mind. I think it's 4, but check.
It is.
Okay, you should have 4. And 4 is good enough for a test. So, and if you don't have 4, if you wasn't here, go check the videos out. You'll be the only person that does. All right. Let's do another. Let's move to another section. So let's go to 5.3. 5.3 and 5.4, whichever section we're supposed to cover, are real simple because we don't have to do anything but use a calculator. For some of you that's on the calculator drill team in high school, y'all will like that. NP and X. Probably what we're going to go over next. Let me get rid of this and move over. Yep, that's what we're doing, NP and X. Might want to write down page 211, the green box. Make a note of that. Tells you what the different variables are. All you're going to need basically is N, P, and X. N is always like N in here would be 25 because there's about 25 students in here. All right, so N would be 25, that's your big number. X denotes a specific number of successes in the N trials, and P is going to be your percentage, okay, or probability. Percentage, probability, area, all those are the same thing. So N, P, and X. Most of you that's going to use the TI, that's all you need to know, N, P, and X. Because Q is going to be the complement of P. So if P is 0.5, Q is going to be 0.5. If Q is 0.6, if Q is 0.6, P is 0.4. So, and your formula is probably on the next page. There it is. There is the formula. Now you talking about a pain. You thought that the permutation and the combination formula was a pain to do by hand. This one's even more of a pain to do by hand. So I would suggest borrow a TI, or make sure you get an app for your phone for the TI. One of the two, because it's a pain. N factorial over N minus X factorial times X factorial times P to the X power times Q to the N minus X power. And that is a pain. Or you can use your handy dandy NPX. And I'll show you where that is. So unless you don't have any access to a TI, you might want to write that formula down. And I'll give you an example. Let's say that you flip a coin 10 times, let's say you flip it 100 times, and you find out that it's a little bit weighted toward tails, because out of the 100 times that you flipped it, 57 of them became tails. In other words, it fell on tails. All right? Then you ask yourself, what is the chance, what is the probability of this coin getting on tails if you flip it 10 more times? All right, so you got a coin, you flipped it 100 times, you got 57 out of 100 tails. And they're asking you, what is the probability that if you flip it 10 more times, the same coin, what is the probability that you're going to get tails out of those 10 times? So that's what it's asking. So your N would be 100, your P would be 0.57, and your X would be 10, because you're going to flip it 10 more times. All right? So that's the kind of question that they're going to ask. If you have this, and the probability of this, what is the probability if you do this? With the same coin, or the same die, or the same deck of cards, or whatever. That's what they're asking. So, as far as this goes, I would not suggest using this unless you positively, absolutely do not have access to a TI, you do not have access to an app for TI, then you would have to use this. Okay, so that means if you have access to a TI and you know your neighbor, don't let them borrow it for a second, okay? Because they don't need to do this by hand. It'll take them 15 minutes to do it, because it's aggravating, okay? Not only are the exponents aggravating, but you have to deal with these factorials, and without the TI, that would be a pain. So, calculator drill team, y'all can be proud. All right, here's an example. Given that there is a 0.85 probability that a randomly selected adult knows what Twitter is, use the binomial probability formula to find the probability of exactly 3 adults who know what Twitter is. When 5 adults are randomly selected. So N is equal to 5, P is equal to 0.85, and X is equal to 3. Okay? Now I'm not going to tell you, there's how you plug it in. I'm not going to go through that because that's a pain. But I will tell you how to do it on your handy dandy calculator. And if you need it, it's under binomial PDF, which is under second bars. I was gonna see if the book tells you, but it should. Let's see if it tells you on the next page. Or the next page. The second bars binomial PDF. But I'll show you how to get there. I guess they don't show you. All this time I thought they had, there it is. Second bars binomial PDF. Okay, there it is on page 217. So you take out your handy dandy calculator. And you hit second bars. Second, which is the yellow top left corner, bars, which is right beside the clear button. Binomial PDF, which is number 0. Now, since the beginning of this section, I've been saying NPX, 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 NPX. One of the reasons I've been saying NPX over and over and over is because that's the way you have to type it into your calculator. If you type it in any different way, it's going to give you an error or an error, depending on where you're from. But you got to type in N, P, and X. Now, in the previous example, N was equal to 5, so you type in 5, comma. P was 0.85, I believe, wasn't it? Yes, Hubert, thank you, class. And P was, or X was 3. Will X always be less than N? Yes. And close parentheses. So, sorry. Oh, Hubert, don't use the keyboard, use the calculator. Thank you. All right. So, we have a coin that we flip 5 times, and out of those 5 times, we got an 85% chance of tails. What is the probability if we flip that same coin 3 times? That's what it's asking. Of course, it's got a different example. I don't know what they're talking about, but I'm giving you an example that you can put in your brain. We flip the coin 5 times. Out of the 5 times, we got an 85% chance of tails. What is the probability if we flip that coin 3 more times? What is the probability of getting tails? And that probability is 14%. Of course, you're talking about 3 times, you know. So that's really not a very good example as far as percentages go. But you still see what I'm trying to get at. I'm trying to give you something to grab onto as far as an example. All right? So the only thing you have to remember on this is make sure you type NPX in order. Because if you don't, you're going to get an error. So let's try nerd. Let's try one in your 5.3 study plans. All right, here's an easy one. Assume that the procedure yields a binomial distribution with n is equal to 6 and a probability of success of p is equal to 0.8. Use a binomial probability. No, you don't need a binomial. You should do a calculator. To find the probability that the number of successes is 2. So n would be what?
6.
P would be
1.
and X would be 2. So you pull out your handy dandy calculator, hit second function, entry, change that to, I done forgot, 6.8 and 2. .015, so that'd be .015. It's a miracle. Golly, I can't believe they still have the tables in here. Dang old, let's see, .8, you find .8 right here, and out of 5, 6, I'm showing you how to use the table. Let me just use my handy dandy whiteboard. Go away. All right, I'm gonna try to do this, but I don't know if it's gonna work or not. All right, so you find n is equal to 6 right here, this little area right here, and x is what? 2. So you use this tape. Well, I tried. Let me try right here. You're going to use this area right here with n is equal to 6 and x is equal to 2, and then you're going to take your handy dandy virtual vertical line and go at .8. And what did we get? .015. Let's see what our answer is. Go away. .015. Now that's how you use the table. And I would highly suggest using the table if you don't have a TI app versus using the formula. All right, let's try one more so you'll have it in your notebook. So when I give you 3 or 4 on the test, at least you'll get those right. Now don't fall into the trap here, because the trap is they give you n, x, and p, and y'all gonna type in n, x, and p, and the calculator's gonna have a fit. Because n, p, and x, it's looking for probability, and probability cannot be 2. Why? It's supposed to be 0 to 1, exactly. So it can't be 2, so the calculator is going to have a part murmur because of that 2 right there. So you've got to flip these 2. So you put in your handy dandy calculator, second function, enter, and type in 6.15 and 2. 0.176. There's a test question. It says a TV show, Lindsay and Tobias, recently had a share of 20, meaning that among the TV sets in use, 20% were turned to that show. Assume that the advertisers want to verify the 20% share by conducting its own survey. And a pilot survey begins with 18 households. What do you think that 18 is? N. 18 is N. Well, what about the 20? That 20, that's nothing to do with the problem. Because what does it say? Assume that an advertiser wants to what? Verify. So you're going to verify that 20% is what you're going to do. All right? By conducting its own survey, and a pilot survey begins with 18 households having TV sets in use at the time of that TV show broadcast. Find the probability that none of the households are turned to that TV show. So what do you think? Well, N is going to be 18. Where is the only percentage in this question? 20%. So P is 20%, 0.2. And then what's the only other number you can use for X? 0. Simple as that. This is a test question. 50% of the students miss it. So take your handy dandy calculator. Second function, entry, and dang old 18, thank you. 1, second function, insert 18, and 0.20, and 0. So does this show really suck? I guess not, because 2% will, out of, 18 houses, only 2% are not watching it. So, it says around 3 decimal places. 0.018. That was difficult. Find the probability that at least one. All right, I want you to do this one. I'm not going to give you any hints, because I want to see how many of you know what the definition of at least one means. Because a lot of you don't. You don't need to raise your hand or anything. Just at least one. If you don't know what the definition is, draw a number line. Dang old number line. Tell me what I want to draw. Hold on. There we go. Dang old elementary school. I suck at drawing with a mouse. Zero, 1, 2, 3, 4, 5. I forgot this thing don't automatically orient itself. The only one in this building is in 236. This room is jinxed. There. All right. So 1 is right here. At least 1. What does at least 1 mean? That means that the lowest number is what? So that means that we need to find the probability between 0 and what? I'm trying to get there. Hold on. What's the other number? 0 and what? 18. So you need to calculate each one. You need to calculate NPX with x is equal to 1, NPX with x is equal to 2, NPX with x is equal to 3. You got to do that how many times? 18 times. Right? Or you can do the probability of 0 and take it away from what? 1, Hubert. That's right. Because what's the only other number? Can you have -1 households? No. So these don't. Just throw these away. Okay? All right. So let me fix this because this is driving me bananas. Still ain't going to be right because it's. There we go. Your population is from 0 to what? 18. You want to know. Let's go with yellow. You want to know from 1 to 18, right? So this whole probability is equal to 1, right? So if this whole probability is equal to 1, then why can't I just take the probability of 0 and subtract it from 1? 1. Can you have 1.5 households? No. These are all whole numbers. There is no probability in here, okay? Because you can't have 0.5 households. 0 households, 1 household, 2 households, and so on. So the easiest way to do this problem right here would be 1 minus the probability of what? 0 households. I don't know why this thing's not right. I guess somebody came in here and messed up the board. Okay, so 1 minus 1 minus the probability of 0 households. Unless you want to do 18 calculations. So we're going to take our handy dandy calculator. I don't know if this will work, but I'm going to try it. 1, turn it on first, Hubert. 1 minus inverse answer. Yeah, I don't think it's going to work, so forget it. Let me just clear it. There. Second entry. And I'm going to do, how many households? 18. So 1 inverse insert 18 and 0.20 and 0. And of course we did that right up here, but I'm doing it again. And that's 0.1018. Now, that is the probability of this guy right here. So I'm going to say 1 minus inverse answer, which is the little negative sign beside the enter, and that's equal to 0.982. So my answer for B is 0.982. It's a miracle. All right, you do this one. It says find the probability that what? At most 1. So you need to highlight, on the previous one you need to highlight at least 1. And on this one you need to highlight at most 1. Because that's going to tell you what you need to do. So on this one,